So here's the another video on the Poisson distribution, and I'm going to cover up the two sample sums that you can see on the screen and the question number 6 and 7. So the first thing is they have given that x is distributed with Poisson with mean lambda and probability of x equals to 1 and x equals to 2 add up to the same probability as x equals to 3. Find out the expected value, find the deviation, find the probability of x being more than or equals to 3. And it is given that x is more than or equals to 2. Find out the probability that x is less than or equals to 4. So, so how do we do this kind of question? So in the first case, I'm just going to quickly write on the formula. The probability of x equals to x is e to the power negative lambda, lambda to the power x over x factorial. Now put in the formula values. So e to the power minus lambda, lambda to the power 1 over 1 factorial plus e to the power minus lambda, lambda to the power 2 over 2 factorial equals to e to the power minus lambda, lambda to the power 3 over 3 factorial. Now, if you take out e to the power negative lambda common, what you get is lambda over 1 plus lambda square over 2 equals to e to the power minus lambda, lambda cube over 3 factorial. So e to the power negative lambda get cancelled, and you get lambda plus lambda square over 2 equals to lambda cube over 6. And you can put this on calculator and solve for the value of lambda. While you're solving this, you can either put this on calculator graph function, or you can use this nsolve function of the calculator. So if you wish to use nsolve, you got to go to run matrix, press option, then you press calc and solve n. And here you type out the function that is your x over 1 plus, you could just write on x, and here it is x square over 2 equals to x cube over 6. And now when you solve for x, you notice the x is 1.37. The calculator setting mode is actually the complex mode. I'll just make it real. So it is real, and you can see the exact values now is negative 1.37, then you get 0, and you get 4.37. So since lambda is positive, so I'm going to take lambda is 4.37 for my calculations. Here they haven't specified lambda being positive or negative, so you could have taken the negative value of lambda until specified so. So the expected value we got was 4.37, and so is the variance. So the variance is also going to be the, so variance is going to be the square root of 4.37. And now they have asked us to find the probability for x more than or equals to 3. So x more than or equals to 3, you got to go into the GDC for the particular answer. All right, so to do this on GDC, basically what we do is go under statistics, go to distribution, then go to Poisson, then you have to take for more than or equals to 3. So go for PCD, lower value is 3, upper you can put a big number, and the average is 4.37. So the answer is around 81% chance or probability of, this is 81.12% chance. Or you can say this is around 0.811. Now, when you are doing this one, this is a little bit of conditional probability. I just rewrite the formula. A given that B, it is probability of A and B over probability of B. So this is probability of x less than or equals to 4. Intersection is probability of, x more than or equals to 2 over probability of x more than or equals to 2. So if I just show to you here, if this is, let's say, more than 2, more than or equals to 2. So this is the outcome, and less than or equals to 4. So that is this outcome. So the common part between both is this is nothing but probability of x between 2 and 4 over probability of x more than or equals to 2. So this once again you do on calculator. So if I just take this as 2 and this is 4, so that's around 48%, so 0. So this is 0.489 over probability for x more than 2. So x more than 2, lower is this and upper is a big number. So that is around 93%. So divided by 0.932. So if you simplify this answer, that's what we needed. I hope this is helpful.